Alright, let's continue with chapter 16, which is normal distribution, which is a continuous probability density function. In 16C, we're gonna look at problems where you will have to determine the probability or the area of the function under the curve within boundaries, or the inverse, which is they will give you the probability, and what you will have to figure out is the boundaries for that corresponding probability. It's all going to be done on the CAS calculator. So let's say you have a situation, it's given to you a normal distribution, you will have the mean and the standard deviation, and it asks you to calculate the probability within boundaries. If you were to do that by hand, you can use the 68, 95, 99.7% rule, but most of the time you will do that on the CAS calculator, as the answer is it's a numerical estimation. Okay, so follow those menus on the CAS calculator. It needs to be on the calc page. It's normal cumulative distribution function. So cumulative, the C will you will specify the first boundary and the second boundary. So this is the screenshots. Now once you get there, you'll specify the lower and upper boundaries. That's your mean and your standard deviation. And then you will get your answer as a decimal, so it's approximately 46%. Now if you want to, you have your calc page and you want to keep on calculating normal distribution probability, instead of recalling the menu, what you could do is use the arrows, move back up, press enter. It will duplicate this function as a new line, and just have to change the values, so the boundaries and the mean and the standard deviation. If you have a situation when the probability is, the interval is x is greater or less than the value, but you don't specify the other boundary, what it means here is x has to go from 60 all the way to positive infinity. So when you use the menu, your upper boundary will be an infinity. If it was x less than 60, your upper boundary will be 60, and instead you will have a negative infinity on your lower boundary. As you calculate it, you get this formula, and then you decimal estimation. To get the infinity symbol, there's two ways you can do that. Control and the library button, and it will display all that menu with symbols and special characters. Another way is the pi button will open some a restricted menu. You will have access to pi and those symbols like theta and infinity. Also, I think it's degrees, maybe, or maybe not. Alright, so when you have a problem, you have it's a normal distribution, you have your mean and your standard deviation. Ask you to find the probability. What you can do is not only get the calculation but also a visual representation. You follow these instructions. Now the first thing is, it's not going to be a calc page, it's going to be your spreadsheet. So you choose to add a page, it's a list, a spreadsheet. You use in the first cell A1, you just use statistics, stat calculation, normal CDF, and you specify your boundaries, your mean and standard deviation, and you tick the shade area, and what you will get is, in the spreadsheet you will get your value, and you will get your normal distribution with a shaded area that represents that probability. Okay, now let's say you have a situation when you work backwards. This time you know the probability. Again, you still have, it's a normal population, so you have a mean and a standard deviation, and it's asking you to find a boundary when the probability is, the variable is greater or equal to that boundary. You will use the inverse normal function. So what it does is you need to specify the area and it will find the boundary. Now with the inverse normal, it always specifies the upper boundary. It means that your probability needs to be in the form of x is less than k. So if your probability as an area is given as x is greater than k, you need to turn it as the complement. So it's going to be 1 minus that amount. That will give you 0.75. That's the complement probability. And by using the inverse normal, you will estimate that k value. Okay, so here you can see that you use 0.75, the normal distribution features. That's your function, and that's your k value that is approximated. So that will represent that amount. So x will have to be greater than 73.1. Yeah. All right. Another situation when you have, again, a normal distribution, and you have your variable needs to be between two boundaries, and it will be equal to a percentage. That is the area. Now by convention, as you have 95%, what's left, the complement will be 5%, and what you need to do is the tails, you have two tails, one on the left, on the right, they will be the same area, so they will be half of 5%, 2.5% on the left, 2.5% on the right. Your C1 value is here, your C2 value is there. So first you need to find the you're going to use the inverse normal function of the 2.5%, and to find that C2 you take all that area on the left, which is your 0.95 plus that 0.025. That is why you have 0.975 here to find the C2 value. By using the inverse normal, you use the mean of 100 and a standard deviation of 6, you get those respective answers. Alright, another problem, this time you'll have the screenshots on the side using the inverse normal function. So here you have a normal distribution, you have your mean and your standard deviation. What is the k so that 90% of the weight lie within k kilogram of the mean? What it means is you have, from the mean, you have a left boundary minus k, above the mean plus k, and it will be symmetrical. So from before, from the previous, you have 95%, you have as a complement 5%, so you're going to have 2.5 on the left and 2.5% on the right. Now you have 90%. What it means is you have a complement of 10%, so you're going to have 5% on the left and 5% on the right. So to find the left boundary, you're going to use inverse normal of 5%, that will give you your lower boundary, which is this one, which is equivalent to the C1 from the previous example. And to find the upper boundary, you use inverse normal. It's going to be that 90% plus the 5% on the left tail. That gives you 0.95, and that will give you your upper boundary. Now to find the k value from the lower, using the lower boundary, you take the let me do that in the right order. So they do that with the upper boundary. If you minus the mean 65, that will give you your k value. And similarly, if you use the lower boundary, if you subtract that lower value from the mean, you will get the same k value. And yes, the upper and lower value away from the mean, they are identical. Is, as we said, from that 90%, by convention, we're going to say it's 5% on the left and 5% on the right, so there's going to be a symmetry on the boundaries. All right. Now, a few more properties you need to remember that are symmetrical properties for a normal distribution. So here, when you have your normal distribution, this is a standard normal distribution, as the mean is 0, and every unit will represent a standard deviation. Now, if probability of z is greater than a is 1 equals to 1 minus the complement, so it's going to be z less or equal to a. If you have z, probability of z is less than negative a, so your negative a is that area. You see that area by symmetry is the same as the other area, so it will be the same as probability of z greater than a, and vice versa. Very useful property, that second one. That second property will be used for the next one. If you have a probability of z between negative a and a, they are symmetries. It's the same as the complement at what we had before by removing those ones, and because they are the same, it's the same as 1 minus 2 times the probability either of z less than negative a or the probability of z greater than a. Okay, so you can use either relationship when you have a probability of z between two values that are opposite. Alright, and that's it for 16C. See you later.